We have a new project to download. So if you go into your GitHub desktop and click on your repos, you want to clone a repository. The one you're looking for is named Command Demo 538. So this is the one you're looking for. And just clone it. Make sure you're not cloning it into a OneDrive folder. If you're using the school laptop, it's not a OneDrive folder. If you're using your own laptop, it depends on how you have your laptop set up. So while we're getting that, I do want to remind y'all of something about Timed Robot, right? In Timed Robot, we had those init periodic pairs, and we put most of our code in the periodic methods on Robot, right? That is how you write code for Timed Robot. You are not going to be seeing that for the Command Robot. It's going to look different. I just want to kind of preface that. The periodic methods will still be there. Robot will still be there, but you will not be putting code in either of those places. So we want to open up this project. So I need to go into WPILib VS Code. It's loading, there it is. And I want to open up the project. How do I open up a project? Open folder, go to Documents, GitHub, Command Demo 538. Open, and again, the first time you download, you're going to have to do the build, so we let that run for a little while and let that get going. All right, so let's look.
I'm going to build it, but you can go.
That's fine. We're going to look in the structure of the project. So just like with a Timed Robot, guess where all the important files live? Source, src, main, deploy, Java, FRC, robot. Now, what's one difference you see right away from when we worked with the Timed Robot?
Robot container Java.
There's another file here. So just like before though, main is going to look remarkably simple. And what did we say about if you're working in main?
You're either doing something wrong or you're super advanced.
Something wrong or super advanced. So avoid the main file. If we look in the robot file, it looks remarkably similar to the Timed Robot example, right? We still have these tests, we have these teleops, we have these autonomouses, we have these disableds, we have robot periodic, robot init, all this stuff is still here, but there's a little bit more to it. There is some stuff in here that they've already set up. And if you notice, it's actually a timed robot. So a command robot is just a very special timed robot. So just like with a timed robot, we didn't touch the main file. In command robot, we're not touching the main file, and we are probably not touching the robot file. It's not as hard of a hard and fast rule here. There are times to mess with the robot file, but they are still pretty few and far between, even compared to the main file. The robot container, though, is one you'll spend a pretty good bit of time in. And so most of this is also not where you're writing code either. In a command robot, you're going to be writing code in other files, files you make. So let's talk about that structure. So in a command robot, there are three key components. One of those components is called subsystems. The idea here is you want to model your robot. You want to break your robot up. So let's say you've got a robot. What are some things your robot might do?
Climb, drive, shoot.
Climb, drive, shoot. Those are things the robot can do. And in most cases, the things that let the robot drive, like the motors you use to drive, and the motors or other actuators you use to climb, are probably different motors and actuators. And so the idea is you want to logically break up your robot into independent subsystems. And that's a key idea there, is that when you design your subsystems, you want to design it so that no one subsystem is doing more than one thing at a time. So for example, you could climb and drive at the same time if you have a climbing subsystem and a driving subsystem. But you wouldn't want a shooting climbing subsystem because maybe you want to be able to climb and shoot at the same time. So independence is important there. You want to make your subsystems things that can behave at the same time, but not do more than one thing each at the same time. And so, yeah, keyword there is independent. So then there's a little bit of a difficulty there as well. What if every motor is a subsystem? Well, that's too specific, right? That's not useful. Questions on the subsystems idea? Okay. The second big idea of a command robot, unsurprisingly, are the commands. Who would have guessed, right? Commands play an important role. Commands are actions. Right? And that doesn't mean the robot has to do something necessarily. Like the robot could sit there and process some data, but it's something the robot is doing. And the idea for commands is commands tell subsystems what to do. Right? So maybe the climb subsystem can raise and lower and stop. Those are the things it is able to do. Well, maybe you want to have a command for, hey, climb at this speed. That's a command. If you want the shooting subsystem to move to an angle, that's a command. So commands are just when you want to tell a subsystem to do something. And commands are useful because you can compose commands. So maybe you want the wheels to line up into a certain position while you're shooting. Well, you issue a command to the shooter to shoot, and you issue a command to the drive to drive, and you can have those go in a different order. You can have them go at the same time. They're very composable like that. So you use commands as kind of like building blocks for functionality. So maybe there's this huge complicated thing you want the robot to do. If you can break that big complicated job into a series of small tasks, and if you can break those tasks into jobs for each of the subsystems, you're basically building a Lego model, right? You're putting the blocks together, and boom, you've got this big complicated functionality through a bunch of very simple pieces. The last thing that goes into the command-based robot are triggers. Now, it's not these triggers, but it could be these triggers. A trigger is a condition. And when that condition is met, it sends the command out. So in step one, you've kind of defined your subsystems. Go ahead.
So like when you're driving, if you press A, that's a trigger.
Pressing A could be a trigger, or unpressing A could be a trigger, or this wheel has spun 27 times could be a trigger. So it doesn't have to be a controlled thing. It could be something the robot's doing could trigger it. And so the idea is you set up your subsystem, say, okay, well, this is what my robot is and what my robot has the ability to do. Then the commands are saying, okay, I want the robot to do this, this, and this using this subsystem, and this subsystem, and putting those together into a job or a task. And then the triggers are defining when that job happens. So, maybe the robot has to shoot the ball when it knows it's 20 feet away from the target. So the trigger is when I'm 20 feet away from the target, the command is shoot, and then the shoot command is using the shoot subsystem to shoot. And so that's what your idea is, that you're breaking it apart, so it's going to be much more complex. And I do actually want to point that out. Two words you'll see a lot are complex and complicated, and then there's the word simple. You want it to be as simple as possible, but no simpler. Sometimes you want to do something that is very complicated, but you don't want the code to be complicated. Complicated is hard, and it is hard to understand, it is hard to maintain, it is hard to do. You do not want something to be complicated, but you do want it to be complex. And complexity is kind of like these Lego models, right? You're building the Lego pieces together in such a way that you get new functionality. So the idea of the command robot is not to make the job complicated, it's to make it complex so that you have these little pieces you can achieve and build those up into the job you're trying to achieve. So at first, the command robot can look scary because there's a lot to it. But just understand, it is not meant to be complicated, it is meant to be complex. And if it's complex, you can break it down into simpler steps and make it work for you. Any questions on this overall idea? So what you're going to find is when you're writing the code, you're going to be making subsystems. Right? And these subsystems are usually, almost always, going to be classes. Okay? You're also going to be issuing and writing commands. Commands are going to be more in the form of what you'll see sometimes called lambdas. Sometimes you'll hear the term runnables. We'll get more into these when the time comes. Just know they're different from classes, although not really, because in Java, everything at some level has to be a class. And then you've got triggers, which are, I'm just going to call them other for now, because they're not classes. They're probably closer to lambdas, but they're more like methods than anything. So you'll be making subsystems, and then these two, the commands and triggers, these are going to live primarily in robot container. So robot container is a special class in the command-based robot. It's just a plain class. It doesn't extend anything. It's just we call it the term you'll hear is sometimes a POJO. A plain, old Java object, a POJO. So POJOs usually are just pieces of data. So the robot container isn't a pure POJO because it does some stuff, but you'll be writing commands and defining your triggers in robot container. You'll also be putting your operator stuff in the robot container. So let's give robot container a joystick. So I'm going to go into the class, go into the robot container. But here's the thing. We're not going to use a regular joystick. There's a special joystick we're going to use. It's called the command joystick. And we'll just make it here. New command joystick port 0. For all practical purposes, the command joystick and the joystick are the same. This could be a joystick or it could be a command joystick. Any idea what the difference between the two might be?
One sends out commands based off of what input you've got going on, and the other doesn't. The other just sends out values that can be read.
So, based on what we just talked about with the command-based robot, what do you think the command joystick might offer you that the regular joystick doesn't?
Runnables.
Looking on this side of the chart.
Subsystem, like it can issue things into subsystems. Oh, okay. Triggers?
Triggers. The big difference between the command joystick and the regular joystick is that the methods on the command joystick are set up to be triggers already. If you just use a regular joystick, you can define your own triggers, but you have to do it from scratch. The command joystick already defines all the button presses and all the axes as triggers for you. And so again, there's no difference between using the joystick or the command joystick. The command joystick just saves you a little bit of work. So right now we've got a command joystick in the robot container, and I think that's probably where we'll stop today, because next time we'll look into what we can do with the command joystick and look more at the command robot. Before I stop the recording, does anybody have any last minute questions?